All right, to follow up on the inverse sine discussion, we're going to go ahead and evaluate some inverse sine values here. One, an exact value done without the calculator. One, a decimal approximation with the calculator. The calculator almost never gives an exact value unless it's just by chance you get something like a 1/2 as a value, or something that works out nicely. Remember that the arc sine is the inverse of the sine, and so with a sine function, the input is an angle and the output is a ratio. But with the inverse sine, the input is the ratio and the output is the angle. Okay, so you're looking for an angle. Now these are going to be in radians. It could be in degrees on your calculator. But it's the rare case that you would end up with something like an exact value, something, if you're in radians, pi over 2, your calculator won't give you pi over 2, it will just give you a decimal approximation for that. Okay, so we're looking for an exact value here. And so we're looking for the arc sine of negative root 3 over 2. Well, with an exact value, it's almost always going to be one of our special triangles. Okay, so when you see that word exact value, think 45, 45, 90 or 30, 60, 90 triangle. And in this case, with a root 3 and a 2, we understand just based on the two triangles, the two special triangles, it's going to be the 30, 60, 90. All right, so just think about that for a moment. A 30, 60, 90 triangle, and the legs or the sides are 1, 2, and root 3. Well, the sine is the opposite over adjacent. So you're talking opposite over adjacent from the 60, it's opposite over hypotenuse. And so we're talking opposite over hypotenuse for the 60-degree angle. And so in this case, the arc sine would be a 60-degree angle, or in radian form, it'd be pi over 3. However, we do have an arc sine that's negative. Now remember, the arc sine output must be between negative pi over 2 and pi over 2. Okay, so it has to be in that interval by definition. And so, because that's how we restricted the sine to get it 1 to 1. And so with a negative sine value, this is essentially the same as saying that the sine of y is equal to negative root 3 over 2, right? These are inverses of each other. And so the angle y is an angle, is negative in the fourth quadrant, right? ASTC. Well, negative signs are in the third and fourth quadrant, but in this interval here, that'd be the fourth quadrant. Here's fourth and first. We want the overlap, so it's going to be the fourth quadrant that we're dealing with. And so I don't want pi over 3, which is a 60-degree angle. I want negative pi over 3 because that's in the interval that we're the interval of the range of the arc sine. Okay, so that tells us that y must be equal to a negative pi over 3 or negative 60-degree angle. Okay, either of those would be sufficient. I'm really looking for the radian value there. The exact value is going to be radians, generally speaking. Okay, and so that's how we would find that. So the output from an arc sine is always going to be, again, an angle in the first or fourth quadrants in this interval specifically. And with an exact value, it's going to be found using one of our special triangles, generally speaking. For this other problem, so let's find an approximate value for y equal inverse sine of 0.2735. Just some random decimal there. This is the ratio of the opposite to hypotenuse on the triangle. Okay, it's 0.2735. So what we're looking for is the angle that gives us that sine value, right? So it's equivalent to saying sine of y is equal to 0.2735, find the angle, right? And so the angle there is found using a calculator. It's an approximate value. So we go to the calculator, and we punch in inverse sine, second sine, 0.2735. Now you guys have done this before, so this isn't new. And so, but there are two outputs, right? You could either get, which one's this one going to be? This one appears to be the degree mode, right? I'm in degree mode. Or I could do the same thing, change my mode to radians, and I get the radian value, right? So you get the degree on top, the radian on the bottom. It's the same input. With the decimal approximation, it depends on how the question is asked. They may want you to round to the nearest tenth of a degree. In that case, you would take, y is approximately 15.9 degrees, right? They could also ask you to put this in radian form and, maybe round to the nearest thousandth or something, 3 decimal places. And so you could also say that it's approximately 0.277, right? Either of those would be sufficient based upon what the calculator showed. All right, so, but again, the angle that the calculator outputs will always be either a first quadrant angle or a fourth quadrant angle. And if it's a fourth quadrant angle, it's going to be the negative form of that fourth quadrant angle, right? It's going to be in this interval. If you're in degree mode, it would be between negative 90 degrees and 90 degrees, right? So every time you do an inverse sine on your calculator in degree mode, the output will be in this interval from negative 90 to 90 every time. You're not going to get an angle of 100. Okay, it's not going to come out of there because it can't. The domain for the sine is restricted, so the range for the inverse sine is restricted. It's going to be in this interval, okay, or this interval, depending upon the mode.